Section 5.5, double angle identities. So we're going to come up with two new identities today. One is for the sine of 2 theta, and one is for the cosine of 2 theta. And just so you get a sense of where we're at here, let's suppose that that's theta, that rotation. So 2 theta would be twice as far. And the x and y values here are definitely not the x and y values there. And so it's not twice the x value and twice the y value, for sure. So we need some way to figure out what are the trig ratios that go with a point that's twice as far around as our original point. Okay, so in order to find these, let's start with, let's rename sine of 2 theta as sine of theta plus theta, right? Because theta plus theta is 2 theta. And even if you wouldn't have thought of this, I'm just trying to justify what we're going to say here. So we know how to do sine of a sum from our last lesson. So that would be sine of theta, cosine of theta, plus cosine of theta, that's the first theta, sine of theta, the second theta. But this is sine of theta, cosine of theta, plus, and by the commutative property of multiplication, this is also sine of theta, cosine of theta. So what we have is 2 sine of theta, cosine of theta. And the benefit of this is now we can use the x and y coordinates for this point to figure out the x and y coordinates for this point. Okay. What about cosine 2 theta? That would be cosine of theta plus theta. And we know how to work that. That's cosine theta, cosine theta, minus sine theta, sine theta. And so this would be cosine squared theta minus sine squared theta. Okay, so I also can figure out the cosine ratio at 2 theta using the x and y coordinates I have at theta. Here's the confusion. Remember, we have sine squared theta plus cosine squared theta equals 1. That's a Pythagorean identity. This now says cosine 2 theta is cosine squared theta minus sine squared theta. See the difference? Plus, minus. So please do not get these two confused. Let's use this. Okay, so suppose we use it with a triangle instead of a point in the plane. So we have this triangle where we know the opposite side and the hypotenuse. So small bits of the Pythagorean theorem. 49 minus 4, 45, square root of 45. That's 9 times 5. So 3 root 5. So the adjacent leg is 3 root 5. So the cosine of theta, easy enough, 3 root 5 over 7. But what would the cosine of 2 theta be? Well, I don't have a triangle that has an angle of 2 theta in it. I only have a triangle that has an angle of theta in it. But I now have my identity, which says, well, the cosine of 2 theta could be found using cosine squared of theta minus sine squared of theta. Oh, okay. Well, what would that look like? That would look like 3 root 5 over 7, right, the cosine of theta, squared. And the sine of theta, 2 over 7, squared. Let me move this guy out of the way. Okay, so this would be, let's see, the denominator is 49. 3 squared is 9. Root 5 squared is 5, so 9 times 5 is 45. Oh, I already knew that. From here, minus 4 over 49. So 41 over 49. Without ever seeing a triangle, I know what its cosine is. So what if I wanted the sine of 2 theta? Well, we now know that that is 2 sine theta cosine theta. These are equivalent. So that would be 2 times sine of theta, 2/7, times the cosine of theta, 3 root 5 over 7. So that would be 2 over 1. 2 times 2, 4. 4 times 3, 12. 12 root 5 over 7. What would the tangent at 2 theta be? That would be equivalent to the sine at 2 theta divided by the cosine at 2 theta. So I know the sine at 2 theta is 12 root 5 over 7, and the cosine at 2 theta is 41 over 49. So 12 root 5 over 7, oh, pardon me, this is 49. I made a mistake. Over 49 times 49 over 41. 49's cancel. So I get 12 root 5 over 41. Good thing I caught that mistake. 1 times 7 times 7 is 49. Okay, let's try it in the plane. So we know that the sine of theta is negative 5 over 8. And this obscure little clue is saying that beta is somewhere between 3 pi over 2 and 2 pi. So remember, 3 pi over 2 is straight down here, 2 pi is here. So beta is somewhere rotating into the 4th quadrant. So that means, I don't know the x, but the y is negative 5, and r is 8. Small bits of the Pythagorean theorem. 64 minus 25 would be 9, 39. So the square root of 39, positive, would be x. Okay. Well, if beta is that big, 2 beta is like around and around, but I'm not sure where. Doesn't matter. The sine of 2 beta can be found using 2 sine of beta, cosine of beta. And I know all about beta now. 2 times negative 5 over 8 times root 39 over 8. That would be negative 10 root 39 over 64. Oh, I could have canceled. 5 and 32. So negative 5 root 39 over 32. Cosine of 2 beta. Well, I don't know what 2 beta is, but I do know that cosine of 2 beta gives me the same answer as cosine squared beta minus sine squared beta. The cosine of beta is root 39 over 8 squared. The sine of beta is negative 5 over 8 squared. So I get 39 over 64 minus 25 over 64, which gives me 14 over 64, which gives me 7 over 32. And the cosecant at 2 beta is the reciprocal of the sine at 2 beta. So 32 over negative 5 root 39. So negative 32 root 39 over, let's see, 5 times 39 is 45. We get the 415, 195. There we go. Give it a try. See what happens.